Hello, everybody. Good to see you again. It seems like we're doing this about once a year. We've had, since I've been involved with Tarana, this will be our fourth major product announcement. And it seems to be fall every year. So I think we're going to have to keep this streak going. When we started, a lot of you here have been with us for a long time through this whole journey. And when we started this project, when we first launched the product, we called the tour, when we launched the product, Seeing is Believing. And the reason we did it at the time was, many of you may remember it, was that the product is a really unique product. And it behaves differently in the field. And people were not used to that. They weren't used to seeing a product show up and do something wildly different. Whether it's a reflection or whether it's interference cancellation, it's just a different product. And that's foundationally true because the product was built top to bottom, from silicon all the way up to software, for fixed wireless, for broadband. So it behaves differently. And we had to call it Seeing is Believing because people really just didn't believe it. In fact, I relay a story pretty often about Ryan, who's probably, I saw him here earlier from SmartWay, had posted something on, I think it was Facebook. And when the product first came out, he was out drive testing it. And he pointed it at a tower, and he posted 1.5 miles from the tower, building in tree obstructions, 450 megabits per second. And it was like, this is really cool. And then the next posting was, turn the remote node 180 degrees from the tower, 600 megabits per second. And then he wrote WTF. And then I sent it to the whole company. And I realized after I sent it, we have a team in India that I'm going to have to explain WTF. So we called it Seeing is Believing. And each year we've had a pretty interesting announcement. And this one I'm really, really excited to tell you about. But of course, actually, you know what I realized is I don't have the advancer. Steve, if you could get the advancer, I think I might have left it on the table. In the meantime, if you could just advance the slide one, it'd be great. Somebody could do that for me. Or not, I can just riff, tell jokes. There we go. This is so another thing we realized as we were working on this product is that it's fundamentally different. We had to describe it differently. It's not really just FWA. We said we have to call it something else. Well, we wanted to keep FWA because that's kind of descriptive and important. But it wasn't the same as traditional stuff, whether it be 3GP stuff or Wi-Fi based stuff. So we called it ngFWA. And ngFWA, when we started, was more of a story, as all companies that build new technology. It starts as a story. But today, ngFWA is something much bigger than a story. And it's really delivering around the world. So if I'm going to start with, of course, you didn't think you were going to get a free launch here, a free launch. There is a commercial at the start here. So you're going to have to endure the commercial. Where are we right now? So ngFWA is really growing fast. In just 3 years, we're now in 47 states. We have about 10,000 BNs out there, actually a little more than that. This is operational, covering a lot of area, about 8 million households passed. Hard to do those numbers, but we think that's pretty conservative. And 140,000 more, and most importantly, perhaps 140,000 households served. So that means 24/7 homes waking up, people waking up and having internet service delivered on Tarana technology, which is a huge, huge accomplishment. And I want to start by thanking all of you for helping us do that. So a round of applause for you guys. It's hard. The technology is hard to build. It took 10 years to build this product. It's a very long development cycle. But it's also, we don't take for granted how difficult it is to acquire a subscriber and to do the installation and do the heavy lift and spend the capital and the time to make it work. So we are indebted to you for that. You can see out on there, there's 3, 5, and 6 gigahertz. You're seeing a little bit of 6 gigahertz out there. Interesting, 3 gigahertz is our biggest seller, our biggest installed base right now. It's nearly 60% of our homes are connected on CBRS in the US. Another thing that's not on this slide, and for those of you on the live stream, we're now in 24 countries around the world. So while we're heavily deployed here in the US, considering our starting only 3 years ago, we're now actually getting deployed around the world. It's pretty gratifying to see that as well in some pretty far-flung places, which is great. The other thing ngFWA is doing is going the distance. And this is a slide showing 50,000 links live. These are real links in 3 and 5 gigahertz, and showing kind of the performance in each kind of in buckets related to distance from the tower. So you can see the average link speed across there's 10 miles there of data is 377.70 roughly for CBRS. So it's a really nice average. These are RF. We take the RF measurements of this, so these are real numbers. And you can see the standard deviation as well. So it's a really impressive product, not only near into the tower, not only line of sight. Keep in mind that this graph includes lots of connections I'll show you in a minute that are non-line of sight, that are in heavy interference areas. So this is to get an average like this across 50,000 links, not obvious, right? This requires some pretty heavy lifting. And the 5 gigahertz is also super interesting because it's well above 100 megabits per second. And you guys know that 5 gigahertz is pretty crowded spectrum sometimes, and there's a lot of operators playing there. So the fact that we're able to operate even at distance, even obstructed, near line of sight, non-line of sight at these speeds is really, really impressive. It's really fun for our engineering team, by the way, particularly, to have this. Because when you start these things and you're telling stories off of a slide, anybody can tell a story off a slide. It's when you've deployed a bunch of it, you can see, especially in wireless, because a single link is relatively straightforward. Can you do a lot of links on a sector? Can you do a lot of sectors overlapping? Can you do it in a high interference environment? That's what matters most when it comes to wireless. And with that said, 6 gigahertz is coming along. This is a 5,006 real 6 gigahertz, I should say real live 6 gigahertz links. And you see the performance there is also doing really well. We don't have as many data points there yet, but they're coming. And I want to point out specifically on the right there, this is our X2 mode, which is 4 40 megahertz carriers. And what I love about this is they really are performing at the speeds that we expected. You can see each of those circles is an actual data point, and that box is around 800 to a gigabit performance in the downlink. You can see the uplink is about 200 megabits. These are really amazing services, and 60% of the links that have been deployed on X2 sectors now are performing at these speeds. So this is taking wireless to a whole new place. Now, obviously, when we do gigabit today, a lot of these are more line of sight. In other words, if you're bending around a lot of corners and if you've got a lot of interference, getting that gigabit. But our mission actually is to continue to expand the number of locations where you're going to be able to get gigabit. Gigabit's an important number for selling the service. Now, one thing I've learned over time is that gigabit is way ahead of what customers really need. But then again, when we're making a competitive offer, it's nice to have it on the line card. And that's one of the things that's really good about X2 mode is you can actually have that on your line card. Another interesting thing that's going on with ngFWA is this challenging norms. One of the problems historically with wireless, and many of you know this better than we do, is that when you start to have success, you're limited by the technology. In other words, you get to 20, 30 subs, and all of a sudden you start to self-interfere. You add another AP, self-interference gets worse. Next thing you know, your service quality is going down, and you have to stop. But here you are. You spent all the time, all the money to market in this area. You're getting word of mouth, right, which is gold, and you can't bring on that next sub or that next 2 or 3 subs. For us, this is really one of the most fun things to see happen is to see the number of our sectors that are getting loaded up. And here we have 750 sectors that are averaging our top by density. Our top 750 sectors have 80 subs on average. Now, for those of you that have been doing this for a while, you know, on a sector, that's pretty good. That's pretty amazing. These are real numbers. Actually, 150 of those are over 100. And we have sectors that are up in the 150, 170. We've had sectors at 200. So this is a new world. So you can densify way more than you could before. And when you're done with a sector, if you actually go beyond, which we hope you do, you can put another sector up in a different spectrum. So this is really different. This has not really been done before. You don't see these kinds of numbers out of the traditional technologies. This one's also wildly fun. A lot of our links are actually really non-line of sight. Not just near line of sight, that's not the Fresnel zone, but we're talking about non-line of sight. And here we're showing kind of measurements that we take on the path loss versus free space path loss, so we can determine how non-line of sight or near line of sight a particular link is. And this is an approximation, but it's pretty close. So you can see 34% of our links, this is 58,000, our 5 and 6 gigahertz links, are, and our 3 gigahertz, I'll get to that in a minute, it's even better, are non-line of sight. This is kind of unheard of. To have a stable service at speeds, and these are all represented in those graphs I showed you earlier. So this is changing how you think about. It's actually a little tricky even because, you know, as an installer, installers don't traditionally have the belief that that can actually happen. So you have to kind of retrain, and we've heard this back from you, I'm just repeating, that people have to kind of retrain on the fact that no, leave it there, let it do its thing. And you'll be surprised. Sometimes it will, in fact, find a path, in fact, find a really nice set of paths. And I'll talk more about that also in a minute. And generally, ngFWA, I would say, is mastering spectrum, I think is a good way to say it. This is interference to noise ratio in 3 gigahertz. And I put 3 gigahertz up here because people think, oh, 3 gigahertz is licensed. It's probably really good. And in PALs, it's good. But even in PALs, there's a significant amount of interference at times. And GA, of course, is super crowded. 75% of our CBRS sectors have what we consider to be high interference. 20% of those are severe interference. So what's the point? The point is, in today's day and age, especially if you're working in unlicensed, but honestly, even if you're in licensed spectrum, interference cancellation is critical. Because even in your own licensed spectrum, even your own PALs, if you happen to have them, or if you have your own spectrum in another area, it'd be nice to use one k equals one spectrum everywhere, and not worry about your own devices stepping on your own devices, which we can do. That interference cancellation is not just about asynchronous interference. It's not just about, you know, working in unlicensed spectrum. It's also making licensed spectrum way better. And that's a story that I think is not as told because most people are not thinking about that. You think license is clean, but actually it's not so clean, especially if you're building a dense area and you have a bunch of base nodes and a bunch of remote nodes in that area. So this technology is really interestingly helpful in almost any scenario. This is also another example of where having our own chips, our own physical layer, being able to innovate really helped. When it came to 6 gigahertz, you know, everybody's excited about the sheer amount of spectrum out there and the fact that we might be able to get gigabit with 4 carriers or 160 megahertz. The problem, one of the problems is, though, if you go to get that spectrum, right, it's not always available the way you think the way you might expect. Because, of course, you have to go to the AFC. The AFC has to decide what power levels and how much spectrum you get. And if you have the ability to have 4 carriers and take 4 carriers in various places and do carrier aggregation automatically in the product, you're going to find in a lot more places you're able to get 160 megahertz of spectrum. And what this is specifically, and this is a really interesting study we did, it was the entire set of FCC set of tower database, and we did this with ComSearch. 76% of the time in rural, we can get 160 megahertz. Using a product that doesn't have carrier aggregation and 4 carriers, 30% of the time. Big difference. In suburban, 89 versus 52, and even in urban, it's 96 versus 58. So it's a really big deal to have that flexibility, and that's kind of foundational. This is not stuff you add with software. This is how the chips are built. This is how the system is built from the ground up. And I would say, okay, maybe this is a little much, but I would say it's generally making life better. And what I mean by that is that it's stable. These are some quotes we get back. Our busiest BN has 140 RNs in it. It's operating flawlessly well at a hitch. The one on the lower left I really love. There was always service slowing down or going down with Starlink and no one to call. And you can call, I guess you can tweet Elon Musk. Sometimes he answers his tweets, so maybe that's one way to get service on that. Then I was at an event where I was offered VTX services with Tarana. It's been a life change. Day and night, there's no downtime. We love when we get these kinds of messages. This is huge because that's what we're really all about, you know, making wireless internet as good as wired. And we'll come back to that because that's our mission, really. It's one of our missions. So this is really great to see. So, and it's also making life better in terms of reliability. This is excluding power events, obviously, because power events are a little bit hard to avoid. but we're at greater than 99.9% availability, which really is roughly the same that most major service providers that are doing wired networks are offering, 99.9. We've exceeded that at this point in 2024 across 140,000 links. So this is all really great stuff. And you guys know better than anybody, if there's one thing that you want to avoid, it's truck rolls, dissatisfied customers, that moment when a customer is out and they're screaming. This is everything. So for us, this really does make life better.
We decided to pick a place to test it first. Some of our network admins got a little cocky and said, well, if it's that good, let's put it to the test. And we had a real good location where we have interference from 4 different other providers that are in the area, very heavy noise. And we said, if it works here, it works anywhere. And so we threw a piece of equipment at one of those towers. We had a customer nearby that we had recently denied service to because of all the noise. And we decided to try them out with one of them first. But this time, not only we were able to connect them, but actually deliver over 200 megabits of service in an environment where previously we had said, can't even connect you.
In the past, we've been sold on a lot of different products that, promise X, Y, and Z and underdeliver. And so my expectation was, oh, this is going to be another one of those products where, so much speed is going to be promised. It's going to come in at half of that. And then there's going to be an excuse delivered as to why, that happened. Which was why I was one of the first people to doubt it. And I'm not afraid to say that I was 100% wrong. I am now convinced. I believe in the product. It absolutely truly works.
We bought a few BNs and RNs in the 5 gigahertz space, and we had heard that it mitigated interference really well. So what Brian and I did was we drove down about 1.5 miles to a local taco shop, right? And we said, okay, if this stuff is as good as they say it is, we should be able to get a connection here. It was 1.5 miles. We couldn't see our tower. It was completely covered by trees. And Brian was driving. I put the RN outside of the window, and wow, it connected. And we were in shock and awe. And we were getting 100 meg at window level of a truck. And so that's what really made us a believer at that point, is when we said, we got to buy this stuff and deploy it. With our traditional system, it might have been a little bit more questionable, and they may have said, well, we don't believe this is going to work. So, but with Tarana, there's no question it will work.
We got Tarana up on the tower, and pretty quickly I wanted to immediately get rid of all the old equipment that we have, because the additional cost basically pays for itself in headaches. We have no headaches with the Tarana equipment. Once it's installed, it works great, always works great.
Previous connections I had, usually it would work seamless without any issues until the day I need it. The fiber links would become a secondary link. And then we also have LTE connections, which will then be the backup for the fiber. At the moment, it looks like Tarana will become our primary.
Apparently, we can get bits across the world. We can deliver them through trees, but we can't get them from there to there. It's really, really tough. This is a particularly rough area. Anyway. So, it's always better to hear from people who are deploying it. And we have tons of these kinds of stories, and I wanted to share a few of them. So with that said, ngFWA is a lot of things. It's growing fast, right? It's going the distance. We're getting really nice distances, really, really good deployments. It's challenging a bunch of norms, right? Working in places where people would think it might not work in the past, because wireless has really evolved here. The foundational technology has evolved. It's mastering spectrum, which makes it better for you in terms of getting higher performance out of small, spectrum that you have available where you're deploying. And it's making life better, according to me. So, it's been a really, really great couple of years deploying with everybody. But it also has one downside that we've heard from you guys. And we do listen, by the way. We don't only listen to the good stuff. We listen to everything. And that is that it's a little expensive. And we've gotten this feedback continuously. And just to be clear, when you build a new product like this, the remote node that we build, that we ship right now, that's on the that you're deploying on houses right now, if you're deploying our product, it might as well be a base station crunched into a small device. That's really what's in there. The technology of a base station that sits on a tower. What our engineering team really did is said, let's crunch that into us. Let's put a Sirius antenna on there, 8 antenna chains, and let's put all the processing required, 2.6 teraflops of processing, and the RF front end to be able to be very smart, not only at the base node. Of course, the base node is also an amazing amount of technology in a small package, but also at the remote node. And then let's cooperate and let's learn the best way to send energy back and forth, and we'll deliver a better product that way. But that comes with cost, right? So one of the things we've been working on for a while now is how do we make this a little bit lower cost? And that's what we're about today. So we're finally going to get to the announcement. One thing I want to say, though, is that you guys know that change is in the air right now. That is to say, there's a lot going on. There's a lot of satellite continues to evolve. 5G is kind of here and there, certainly in a lot of places in dense areas especially. Fiber continues to be built. Uncle Sam's about to put $42.5 billion into the system just to make it more interesting. As I was talking to Jim O'Brien last night, I'm sure he's here, but he made a comment which I thought was really worth repeating. This is great, which is that free money can be really expensive. So you have to be really careful. The point I'm making here is that this really is a different world we're heading into. More choice, a little more competition for sure. These kind of different economic headwinds or tailwinds, depending on how you're looking at them, it's changing things. So that's why we're bringing this to market right now, the RNV, which is V is for value, and this is ngFWA, but more affordable than ever. Let me tell you about the RNV. I'm going to take a few slides to describe it to you. And actually, I happen to have one here. It's actually, you might have been worried because this would be a little bit difficult to install in a house. So we shrunk it. The good news is this is a last minute thing. It's actually right here. So the RNV is actually a real product at this point. And we've got it out and around the city in San Jose. We're testing it. It's certainly been in our labs for a while. It's a slightly different aspect ratio, as you can see. It's a different product from that standpoint, and I'll explain why in a second. But it's real, and it's going to ship in Q1. We'll talk more about that in a second. And the big distinction with the RNV is it's lower cost, and it's a little bit less capable on non-line of sight, and a little bit less capable when it comes to interference mitigation. But when I say that, actually, we did something in the design to kind of earn some of that back. So it's a very nice price point, and you get a lot of the Tarana that you expect from our products. This is not us taking a Wi-Fi chip and deciding to go that direction. This is Tarana technology through and through. It's our chips. It has all that fun Taronic stuff in it, because we're not really going to go build a product that's not going to deliver what you expect us to deliver. Well, let me share a little bit more about what's going on with this product. So the current RN has a wide aperture. That means it sees 90 degrees of energy. And the good news about that is you can take a lot of multipath. So you can see a lot of reflections, a lot of signals, and you can actually, if you have a lot of processing, which we do, we can add that back together. We can really do really great things. We call it near perfect multipath integration. So we take all those different reflections and refractions, and we basically add them back together in the digital domain. That's how we get that really high performance, even at cell edge, where normally you would have a lot of fade. The other thing we have to do, though, is when you open the aperture like that, you have a lot more interference, right? So you have to have the smarts to be able to cancel that interference in real time. So you can't open the aperture of your antenna system and not have that interference mitigation. If you don't have this, it's going to be a complete disaster. So most products out there really narrow the beam to try to avoid hearing signals. But if you do that, you lose some of that multipath benefit. You lose some of the non-line of sight behavior. So what we've done here in the RNV is we said we're not going to narrow the beam so much that it doesn't see a pretty interesting amount of space. In other words, it's a nice wide beam. It's 20-degree aperture. But we're going to put 4 antennas instead of 8, 4 antenna chains. And we're going to allow that will give us the resources we need in that narrower aperture to still do all the things we do. Multipath integration, but in a narrower space. So what does it mean? It means it's pretty good. It's really good at line of sight. It's good as a current RN. It's really good at near line of sight. It'll do some non-line of sight. It's just not quite as good as the RN in that regard, but it's way better than anything else out there. So I'm going to explain to you I'm going to go through a few more slides on this. I'm going to tell you why we built this and where we think it fits. What are the applications for this product? I think it's going to be widely used. It's a great product. It has a really nice price point, and it gives you a lot of the Tarana goodness that you're used to already. Another important point about the RNV is it connects to the existing BNs. So if you have 5 gigahertz BNs or 6 gigahertz BNs already out there, this will connect to them. And it connects simultaneously with the other RNs we have. So you can have a 5 and a 6 and a 6 gigahertz full RN and an RNV all connected to the same sector. The RNV doesn't do gigabit, it does 800 megabits downlink uplink. Very similar to the original RN, is 2 carriers of 40 megahertz, right? Whereas the RN6 has 4 carriers of 40 megahertz. And for completeness, I put our CBRS SKU on here, which connects. You have to have a separate base node for that. And as I'm putting the slide together, I thought, wouldn't it be nice? It wouldn't be a cleaner slide if that was just one base node. So I think I'll talk to the engineers about that. Maybe we'll talk about that some other time. But obviously, this is a really nice thing because we're not normally in this business, new technology comes with a new tower climb. In this case, it's not the case. You can just buy this and start plugging it in right away. And our price point is really, really, really a big step for us. Thank you. I think I appreciate that. I really appreciate that. We got to think long and hard about this, right? But we recognize a couple of things, a couple of applications that we think are particularly interesting right now. One is swaps. We know there's a lot of infrastructure out there that needs to be upgraded. And it would be great to be able to upgrade it with Tarana, but Tarana was a bit out of reach for that. Because as you know, when you're doing swaps, you don't get new revenue, you get to save revenue. And it's a little bit harder from a capital point of view, capital allocation point of view. But on the other hand, with the competition coming into the market, it needs to be done. So one of the things we're after here is to help you, go out and take down the 5 or 6 APs you have and put in a new Tarana system and expand your business instead of slowly losing your business because you don't have the right SLAs for your customers. So that's one application. The other application is an obvious one, is lower ARPU markets, where you really need a lower price point. And in fact, they are happy to have a lower tier service. Now, make no mistake, the RNV does amazing service. You can offer 100, 200, 400 meg services all day long on it. But you can also do a lot of them at lower speeds. And this gives a better entry point for lower ARPU locations, whether they be worldwide or even in the North American market. So this is going to be available in Q1, as I mentioned, but we want you to get started now. So we're also going to do a couple more things to help out, to kind of get moving on these swaps and upgrades. First, we're going to drop, for a limited time, we're going to drop the price of our 5 gigahertz full RN to $450. And that has the full aperture. It has all the fancy tricks. It does more line of sight, non-line of sight. It's a great product. We're still deploying quite a bit of 5 gigahertz. Even though 6 gigahertz now is taking a lot of the lead in a lot of places, we still see a lot of deployment of our 5 gigahertz product. We're also going to do a limited time special on the base node, because we know the base node's a big expense as well. And especially big expense when you don't have any subscribers on it, when you first put it on a tower. So what we're going to do there is we're going to basically make the entry price for a 6 gigahertz RN $9,000, whereas normally was around $12,000. And that price is all you pay if you have less than 20 subscribers. If you get over 20 subscribers, you've had some success, you can unlock it for the full price, and you're off and running. So this just helps you get into it a little bit easier. You don't have to pay quite as much when you put up your base nodes. What are we after here? We're trying to help you guys get the 6 gigahertz base nodes up on towers. Start with our 5 gigahertz RN at a nice low price, and we'll be ready to help you out in Q1, end of Q1. When I say Q1, it's the end of Q1. Did you know that? You probably did. End of Q1 to take the RNV, which I think you're going to love. We can't wait to get it in your hands and have you test it out there. I think you're going to really be impressed with it. We're actually, I would have to say, Rakesh is here, our engineering team is listening most likely. we're impressed with it, honestly. These are designs that you don't really fully know. You can simulate, you can model, but you don't really fully know until you actually have it in the wild. And you're testing and you're seeing how it's behaving with interference, with non-line of sight. And we're really impressed with the performance of the product. Of course, I would say that. I'm the CEO of the company, so what do you expect? I'm unimpressed with the product, but I hope you buy it. No, I'm kidding. So we're in Vegas, so of course you have to have something related to Vegas. So what's your play? What I'm really saying here is, by the way, I've never gotten that hand, and I wish one day I would. That would be really cool. If I did, I'd probably like bet $10 on it, though. That's the problem. What's your play? What we did here is just a really small exercise, but it's an indicative exercise. And then I'm going to have Sebastian from VTX come and talk a little bit about their experience with Tarana. He's graciously agreed to be here, so he'll be up on stage in a second. But before we get there, I wanted to comment a little bit on how we see the swap situation in particular. If you're sitting there with a legacy system and you have a bunch of APs on a tower, and we've got that tower there, which we like to show with a ton of radios. But let's say you have 5 or 6 radios on a tower, and you might have earned over a period of time some share, and you're sitting there with maybe SLAs that aren't quite up to snuff right now, and the competition is starting to come at the edges here and there. And so you have some churn. So what we modeled is kind of intensifying competition over the next 7 years. This is a 7-year model we ran. And basically showing kind of the churn worsening with time, which I think is probably correct. A $70 ARPU throughout, but a steady loss of subscribers. And we're saying, hey, this is kind of a roll the dice scenario. You can roll the dice and see maybe the competition doesn't come, maybe it doesn't happen, maybe I keep my subscribers, maybe I can kind of keep sweating the asset. The other option is to play to win, and that's what we like to say is what we're trying to help you guys do, which is spend the money up front, about $200,000, I'll show you that in a minute, for a tower to swap the BNs, increase your range, so you immediately can address more customers in a community you're already in, where you already have some word of mouth theoretically. Increase your range immediately so you can actually market to more customers. Allow you to take on more customers because the sector can handle it on a single sector. Consolidate your infrastructure so it's more reliable. Make life a bit better. Offer better SLAs. And then reduce your churn. So this is the alternative, which we think is the right answer, because the goal is having the subscriber and keeping the subscriber, obviously. So we modeled this over time, and of course, in our model, play to win actually was much better. Surprise, surprise. But we know these are just models, and when it really comes down to it, it's about your situation. It's not always 4 sectors. It's not always this dense. What we showed here is at the end of 7 years, you have 670 subs on this particular tower. Very achievable in some places, not so in others. And we show kind of the net present value, and we did a pretty conservative thing here about what the value of using a 50x EBITDA. So it's like we looked at it and said, hey, does this pan out if you can put the cash into it? And the answer is yes. Of course, the key is getting the more customers and executing on it. But the technology has changed what's possible. And this is now possible. It's possible to fight, not only fight to grow, in a situation where a few years ago, maybe it would have been very tough to do that because you had to get either cash for fiber, which takes an immense amount of fortitude. And of course, this is much, much slower. So with all that said, I want to, and thank you for your time. I'll come back up on the stage and take questions in a second. I wanted to invite Sebastian now from VTX to come and tell a little bit about their story, because they've had some similar experiences with churn and with kind of their infrastructure. And then I'll be back up to join Sebastian for Q&A.
Thank you, Basil, and thank you to the Tarana team for giving me and the VTX name to be up here and share our story with the rest of you. VTX One, it's a rural ILEC and CLEC out of South Texas. We are headquarters in Raymondville. We currently cover, between natural growth and acquisitions that we made over the years, about 40,000 or more square miles of South Texas territory. Have about 36,000 subs. We've been doing fiber since the late 90s. As an ILEC, we invested early on fiber to connect our exchanges to overcome those distances. But even at that, eventually fiber to the home became a thing about 2006. we were doing fixed wireless back in 2001 when I started the company. And long story short, today we count with about 300 towers that we operate and about 6,000 fiber route miles of 100% buried fiber optic infrastructure. So we've seen what each technology can do and what the challenges are for each. And we've always approached this from the best tool for the best, the right tool for the right job. That has always been our motto. We've been coming to the WISPA show since about 2013, and we've seen what the industry has evolved to be in our fixed wireless world and how we accepted the different challenges of having to serve those hard to reach customers. Now, we in Texas have especially in our area, a fairly flat territory. So it may seem like it would be easier to deploy this sort of thing and get the kind of speed that we are looking at. But also that means we have less trees blocking the noise from outside. And our techs in the field will love the flatness of the territory, easy to find the line of sight. But for the guy that has to manage and administer the tower, that means I see more of that noise. And so in between all that territory, we have areas in the hill country, anywhere from outside of Austin, Georgetown, all the way down south to the border with Mexico. So we have different territories and different foliage, different challenges, and different noise levels all over the place. So with our Tarana journey, I first met George Hellman, which I know is in the room, in the bar that's 50 feet that way. And he told me some of the things that we were looking at and the features that we would be able to have with Tarana. And when he said we would be able to tolerate a signal to noise ratio of -10, I turned around and I was ready to leave. And I said, well, I first had to know, because I've been doing this for long enough, and I know this kind of claims have been made before. And so I like to understand how you can sustain that, because if I can do it in 1 out of 3,000 customers, that's not good enough. It needs to be reproducible and sustainable for me to consider this, especially at this price level. So we went to the first Tarana event in St. Louis, the first Seeing is Believing event. And you might have read about my story already, where Mark Castillo, my network manager, who's right here, texted me and asked me, have they knocked your socks off yet? And I said, I don't even have feet left on me to put socks on after what I've seen today. And that was the beginning of this. And so after that, we took it for a test unit. We put it in a location that you saw in the video, where we were seeing several other competitor towers in the area. The noise that we were receiving from them was intolerable. And that's why we said, if it works here, it has to work. It has to be everything they claim. So we put out to the service, and we found this one customer that we had just denied service to. We called them back and we said, would you let us run this test? And this may be what, we know we had to turn you down, but we'd like to prove it here. And sure enough, we were running 200 megabit bandwidth tests to this customer as a test case. In our first advertised tower was in about late 2022, where we set up our 4 VNs. And we went out and said, okay, we're open for business. Let's try to advertise the new packages. Let's see how many customers we can gather and see how this performs under load. One of the first rounds of calls that we made to customers to inform them of the new promotion that we can offer higher bandwidth for less price. I had the story from one of our customer service ladies who made the call. And when she said, we can offer you up to 400 megabits for this price, the customer on the other end hung up. And he called back and requested another lady who he's already been familiar with and said, is this true? And the lady said, yes, it's true. Well, I thought it was one of those scam calls. He couldn't believe that we were able to deliver that kind of bandwidth. And so that started a trend, right? And it just made us more confident with the product, started rolling it out a little bit more. But there was still that barrier. Say, well, you have 2 towers, you have 3 towers, you have 200 customers. It all works great. Our technicians love it. They can't seem to find a way to break it. And they say, well, that makes our life easier, but is the economic model there? Can we make this sustainable in an economic basis? So we caught ourselves figuring out that we would either have to build more towers to continue shrinking the footprint and enable higher modulation rates, or build more fiber, all of which includes spending more money. And we caught ourselves in this black and white thinking mode, because some of us have been there long enough in our industry to say fiber is expensive and wireless is cheap. And anything outside of that, it just doesn't seem right. And then we caught ourselves on that and said, well, but we may be looking at a big higher cost, but we're delivering fiber-like speeds. And so that kind of began to break that model, that new norm that Basil was talking about. And it became just plain and simple, impossible to figure out, to do it any other way, right? It just seems to work. And I mean, mind you, by this, we continued to doing some of these upgrades and running out tests. And even at 2,000 subscribers in, we were still finding places where we said it's going to break this time, and it didn't. And we added another one and another one and so on. So once we started looking at that and we figured out, okay, let's see what impact can this have on our bottom line as we start looking at the churn. Before we started this process and early as we started, our churn was reaching unsustainable highs. In some cases, I remember looking, I believe it was 2022, at a yearly rate, and we were looking in some areas and some markets going up to 12% for the year. And when we took that same churn list and say, hey, let's filter out now a year later all of the Tarana numbers and look at those customers only over the entire customer base, now we were under 5%. And being the sample size of what it was, as it grew, it started showing that was very steady churn rate, because you still have people who move, different reasons why they leave you, not necessarily because your prices are not competitive or another providers in the area. And so by March of 2024, our Tarana upgrade rate has surpassed that of the churn. What that means is what we did is we trace a virtual line in the sand. When we would upgrade a tower, we would look at how many customers that tower had at that time and take a snapshot of that. And then we continued to do the upgrades and converting customers over to Tarana. When a new tower got upgraded, we added to that line. So that number of legacy customers kept growing, but the Tarana numbers were a little bit slower because obviously it takes a truck roll and you lose customers in the process because of that churn. Well, by March of 2024, no matter how many towers we kept on adding, that rate went up. So it means we had turned a corner from the existing customer base to the new Tarana. And so while the ARPU generally continues to trend down year to year, that's just our industry the way it is. The ability to keep more customers meant that we kept more of that revenue. And obviously we did add new customers, but every customer you keep, when you have this kind of churn rates, it's almost like having a new one. So one other thing that we have to also realize when we compare churn, because we compare it to whether we go Tarana or go fiber, is that you will tend to think that the customer that churns is a customer that churns, but in reality, a customer that churns fiber is materially more expensive because you're leaving behind a drop. It could be worth anywhere from $200 to even thousands of dollars, depending on the location and the length of that drop. So when you look at that, even if you still have a little bit of churn on Tarana, the same churn on fiber in economic basis is actually more expensive than your churn in wireless. So what other fights? I mean, we were recovering our churn, but there's some cases where you have HOAs coming to you and say, we want fiber. We have a neighborhood, the HOA board comes and says, would you be willing to bring fiber to our neighborhood? And no matter how much you tell them that you have something different, that wireless can do it, they hear in the news, they know the fame that fiber carries, and they say we want this. So we still do it. We still do fiber. Like I said, we believe in both technologies. And we make the move to try and do this. There's meetings, there's getting permits, there's all the work that goes into running fiber. I'm going to keep a story short, but we go in and another company wins that bid. And we said, okay, well, we can upgrade the tower that's in the neighborhood. We already had some customers in it. We put Tarana on this tower. And to this day, even though there's 300 plus homes in this neighborhood that have access to fiber, we still have half of them and haven't been able to erode that. And in fact, it slowly grows to a higher number. So you can win that fight against fiber at a lower cost, even if you focus on the speed and the package offerings you can be competitive and you can win that fight as well. So it has been nothing but success when it comes to the effect that this technology has had in our business. And we cannot, you can look back, like I said, thousands of installs and still find that one where you expect that it's not going to work. One other story I can refer, we were working on getting a public-private partnership with the local county. And one of the city commissioners had our service. And when we started the conversation with them, we told them that we were looking at a hybrid approach. And we would do fiber in some areas, wireless in others. And he's like, I have your service. It's not that great. And then we look at where he lived and we looked at the map and we said, well, sorry, we missed you, but we actually have better service there now. And we scheduled it and we did the upgrade. And not only did we win that public-private partnership, but he's now telling everybody about it and how great it works. And while there was a whole lot of other work that went behind the scenes on the design and the work to go get that partnership with them and go after grants, definitely that made an impression on that city commissioner and helped us start this partnership with the county to go after grant money. So I can tell you lots of stories, but I think that the numbers and the examples that speak for themselves. And so with that, Vaso, I pass it back to you.
Perfect. Always better to hear from someone who's actually in the trenches doing it. We're building the product, but actually have an experience of getting built, rolling it out. But I just want to remind that Tarana's an interesting company. It's a very deep engineering company, right? It's first and foremost an innovation company. So with an extraordinary team that has done over 10 years of work prior to the product shipping, 10 years, a reinvention of wireless from the ground up. I mean, really what this is. I mean, it's just starting with a clean sheet of paper, which is very difficult to do. But I think there are a couple of things that I want to relate to you about. First of all, we're your engineering team because we're here to help you guys make it work. I mean, we don't win if you don't. It's obvious. I personally agree 100%. And what I've seen is I believe where we're at right now is securing a customer. 5 years from now, when we look back, people are going to recognize that actually securing a customer with wireless, securing a customer with fiber is no different in value. If a customer's happy and getting more bandwidth than they can use, they're not answering ads, you're going to have that customer. And I actually think the value of a wireless customer and the value of a fiber customer is going to start to converge a bit over time. That is an ngFWA, or let's say an advanced wireless customer, because you have to have the performance that makes a customer feel like both reliability, all aspects of it, like they're on a network that's a no compromise network. Right? So that's one of our missions. We're a bit of a mission-driven group, actually. And one of our missions is that, wireless can be end-game broadband. It's not a stopgap to anything. It can be a long-term solution. And part of that equation is, in fact, that we are getting pretty far ahead of what customers need in terms of bandwidth. So when we're doing gigabit-style links, and of course we have a roadmap that goes beyond that, we're pretty confident we can stay well ahead of customer demand with a wireless infrastructure. So that's one of our missions. The other one, of course, is to help close the divide, which what we all, I think, are gratified by in our communities, to be able to help people who don't really have the options, to have another option or have an option of any kind. This only becomes more important with time globally to solve this problem, and we're really excited as a group to have, and kind of honored, honestly, to help here. So with that said, I want to thank you for attending. We're going to do some Q&A. Exciting for us to have this new product to kind of bring the price down a bit, go a little bit deeper, go a little further with you, hopefully help you do some swaps or enter some new markets. But I want to take a bit of time to answer any questions. If you have any questions for Sebastian as well, I'll pull him back up on the stage if you have any questions for him also. So with that, thank you very much, and let's go to Q&A. We got roaming microphones, so if you want to ask a question, just hold your hand up, stand up, come up to the stage if you want to. Oh, here we go.
While you're getting there, there's a question from the live stream about the mobile install app. Wanted you to comment on how's that going in the field and how are people reacting to it?
Yeah. So we actually have I actually asked them to put a picture. It's right here. Yeah, so we finally got the mobile install app out, and it took a few iterations to get it to good, but it is now, I think, getting pretty good uptake. And so we're seeing a lot of people really appreciating this. Obviously, it's really helpful that we're getting now a crop of batteries that have Wi-Fi in them that power the RN. So you can actually just have that little app, and you're up and running. You can actually do an install. So we've come a long way on this. If you haven't already, if you're deploying Tarana and you haven't already looked at the install app, or you haven't decided to try it out, I think it's getting to a place where it's actually really, really useful.
And we also have a nice demo of it in the booth on the show floor, so you can.
This is LinkTech's product, by the way. I'll give them a little ad. So it's a LinkTech product that's one of several products that are now shipping to do this, to help with the install.
Will the new RNV, will it be sold as like an individual unit, or will it be sold like in a 5-pack or a 4-pack?
You mean the RNV? Actually, I'm not sure the answer to that question. I think we normally sell in 5-packs, but I think we sell, is George here? It's in a 5-pack. Yep.
And if I can ask a follow-up question, will that 5-pack include like the mounting bracket with it as well?
Yep. George, yes, it will. It'll have the whole thing. Yep. Yep, got one over here.
I'll meet you halfway. So obvious question, and give me if I missed it. RNV CBRS. Is that gonna be a thing?
Right. We don't have any plans for a CBRS version of this yet. So it's not on our roadmap yet. We have a bunch of really cool products coming. We know about it. Obviously, in the case of CBRS, most people are using CBRS for really long reach line of sight stuff because the spectrum's a little bit better for that. So in some ways, it's not contradictory because it brings the cost down, but it's, the purpose of CBRS is often, longer distances, more non-line of sight, and so in some ways it's not quite as critical. However, it's on our, we're aware of it. Not scheduled right now.
And then quick follow-up, RNV with band 1 for 5 gigahertz.
For 5 gigahertz. Yeah, we don't have that available. Don't have a plan right now for an RNV that comes down to Uni 1. Yep. There's a bit of a trade-off because we wanted to get all of 6 gigahertz all the way up to Uni 7, and there's some limits to what you can do in terms of the total spectrum you can that we'll try to break over time. We'll try to fix that. Yeah.
So I got a question. Last year you mentioned carrier aggregation with 3.5
Yep.
and 6 gigahertz, and I haven't heard anything about it. Where are you guys at?
Yeah, that was my little my little comment about that one graph that said, wouldn't it be nice if that was like one unit? So the question is, what about carrier aggregation that maybe combines beyond just Uni 3 through Uni 7? And the answer to that question is I can't officially comment on it, but why can't I? I'm the CEO. Why can't I say whatever I want? So we're obviously we look at that as a really good opportunity for us because we're unique in having our own physical layer, our own chips, so we can actually do that. Now, when you build a product like that, there's a lot of trade-offs you have to think about. So it's not a small project, but let me just say we're very aware of that particular opportunity.
What about G2?
That's I don't know anything about a G2. What are you talking about? Yeah, so we do pretty much in a product announcement every year. I think you can count on us doing another one, and it's going to be a good one, by the way. It's going to be a good one. I'm looking forward to that one. I think we're going to go right to G3 though.
So with the smaller lens, is there a level of difficulty increase in aligning? Like one of our technicians' favorite things is they can go out, stick an RN out and have it pointed, off into the sunset when the tower's behind them and suddenly they got a connection. So it's allowed them to be very lazy. And I wondered, is the lens change going to change that?
Yeah, it's a great question. And the answer is to a degree, it will. Because you won't be able to be quite as sloppy, let's say, but you still have a 20 degree. I mean, that's a pretty wide beam. And again, I made a really important point that it's got all the Tarana tech in it. So it will beamform. In fact, it will beamform really well. It's going to have very sharp beamforming and very good null forming. So it will do a great job in that aperture. Now, you won't be able to as reliably be outside of that aperture. If you're outside of that aperture, you're going to have to get a reflection. So you're going to have to, but 20 degrees is you can still be pretty sloppy and relaxed. You probably can have 2 beers, not 3, or something like that.
I won't tell them that.
Yeah.
One follow-up. Are these RNs the same speed at finding connection and going through all the steps? Are they slower, faster, same?
I don't, Rakesh, I think I was going to say the same, but I'm not really sure of that. I think maybe a little bit less because it has less carriers. Rakesh, do you want to answer that one? Exactly the same.
Thank you.
Yep. And we're always trying to improve that, by the way. That's something we've been focused on for a long time, is the search time and bringing it down, making it quicker, and giving you feedback during the search. Because one of the things we got feedback on to us is that, hey, this thing is sitting there doing something theoretically, but you're not telling me what it's doing. So I don't know when I'm supposed to say, okay, give up. So we're adding a lot of stuff in the install apps. One of the other reasons to have the install app will give you that feedback along the way. Here's what's happening now. Here's what's happening now. We're trying to make that better so that installer has more information. It's a wrap. So hey, with that, thank you everybody. Appreciate your time here today. Appreciate you joining us. Thank you for everybody on the live stream. Have a great one.